Excuse me. I really love seeing people taking the advantage of the opportunities to rework problems on their homework. Remember, you get full credit back, so might as well. Okay. All right, so we're gonna get into more story problems today, but they're gonna take a little bit more work to solve. They're gonna be two-step equations, which means there's probably gonna be more information. Okay. So the way that we have this set up is gonna help you organize your information a little bit better. Okay. So the first thing you're going to do is you're going to make a list of important information. Okay, you remember yesterday how we highlighted? We're still going to highlight, but now with our highlighted information, we're going to kind of list it out. That way it's like all right there for us to figure out what to do with it. Okay. We're then going to define your variable, just like yesterday. What are we looking for? Okay, and we're going to let a letter equal whatever that question is. Okay. We are going to create an equation that includes our variable. Now, this time we need to think about what things change and what things don't change. Okay. Because there's going to be a few extra pieces of information. Okay. Like if there's a one-time fee, then it's going to be a number that's a constant. Okay. But if there's something that happens multiple times, like you have to pay $12 every hour, that is something that is going to be a coefficient. Okay. So we're going to have a constant and we're going to have a coefficient to our variable. Okay. The key here is what is staying constant and what is changing. And we'll talk about that through our problems. Okay. Then we are going to solve our equation, just like we solved all of our equations on that blue worksheet. Okay. Think about your answer. Does it make sense? Check it with your work. Okay. And then of course, make sure you label your answer. Okay. So what we've done for you in this notes sheet, as well as the first few problems in your homework, we have it organized to where you are going to do those steps. Like we're forcing you to do those steps. Okay. So go ahead and read through number 1 for me at your own pace. Read through number 1. Not yet. Yeah, let's get through notes first, okay? So read through number 1 so we can go through it together. Okay. Arisa, you're reading it to yourself. Oh, you're reading it too. Okay. Okay, so Jamie is running a canoe while she's on vacation. How many of you have canoed before? Okay. I would rather do like a kayak than a canoe. Okay. She paid a flat rental fee of $85 plus $7.50 each day. Her total cost was $130. Okay. And then I'm going to underline how many days did she rent the canoe. All right. So what I've highlighted in yellow, that's our important information. Okay. So important info. She has a rental fee of $85. Okay. We are paying $7.50 each day. What's another way to say each day? Per day. I think per was one of those words for us in our list of operations. Remember, we all purred like kittens that day? Or I did. Well, it sounded like that. Every time I say per, it just sounds good. Okay. And then she had a total cost of $130. Okay, so there's our important information. Now we underlined the question, how many days did she rent the canoe? Okay, so when we go to define our variable, what's it going to represent?
How many days?
Okay. So I'm going to make it D. Days she rented the canoe. Okay. So now writing the equation is not quite as straightforward as it was yesterday, but that's fine. We're totally capable. Okay. So her total was $130. So I'm going to start there because I know that that is what my equation needs to equal. The total is $130. Okay. So you remember how I talked about the constant versus what's changing? Okay. $85 and then the $750. Which one of those is the constant? It doesn't change. What doesn't change? The amount.
85.
The 85 never, it's always 85. The rental fee is $85, but then she also has to pay $750 per day. So 85 is our constant, but then we're going to add on the $750 per day. So I'm gonna multiply 750 to X because of that per day. Okay, so look at your equation. What questions do you have about how we set it up?
I mean addition.
But it could be subtraction. You're right. Okay. So let's talk about it again. 130 is my total. So I wrote it on the right side because that's what we need to equal. Okay. 85 was the rental fee. That's not going to change. So it's a number by itself. And then we added our $750 per day. So if I wanted to rent a canoe for 5 days, I would take 85 and then I would add 750 times 5. Okay. But why did I put X? Is that bothering anybody else? What did I say it should be? I put D, so I better use D. Otherwise that doesn't make sense. Good job, Miss Holman. All right. So now we get to solve our equation. Thank you for your enthusiasm. Real or pretend, I'll take it either way. Okay. All right, Tyler, what's our first move? That's okay.
Oh, yes.
Subtract what? Yeah, 85. We need to subtract 85. We need to undo that 85 first. So we're going to subtract 85 from both sides. What's 130 minus 85? 45? Okay. So then what are we going to do with that 750D? What do we need to do to each side? We need to divide by 7.5. Okay. Bennett, it looks like you grabbed a calculator. Can you take 45 and divide it by 7.5? 6? So let's think about this. Probably a good thing we didn't get a decimal. If you got a decimal that represented the number of days she rented a canoe, that might be a little iffy. Okay. Bennett, in your calculator, could you take 85 plus 7.5 times 6? Do you get 130? Oh, that's so great. Okay, so our solution is she rented the canoe for 6 days. A lot of canoeing. What I want you to do is read through number 2 and list the important information. Read through. Read through.
No, you say you can't go the first and last 10 minutes.
I think you're making things up now.
No, I'm not. I tell the teacher say I can't go the last 10 minutes.
And I'm saying you'll be able to.
My goodness, but then it's like 3 minutes left. I can't do it that long.
You'll be okay for at least this example. Make it through this example, and then I can you get your passbook out. So it's pretty. It's the last day of the pass.
Stop.
And do this example, and then I can let you go. Go get your passbook out. Okay, so important information. $50 to go to a movie. So that's what you're spending, right? You're spending $50 at the movie, right? Okay. You know for sure you want $20 worth of food at the or drinks at the concessions. And you know that tickets are $7 each. Okay, that's probably a good clue right there, that $7 each, that you could be buying more than one of them. Okay, now let's look at the question. How many tickets can you buy? So that gives us our variable, right, Brady? What do you want to call it? What about T for tickets? T for tickets, okay? Our variable T is the number of tickets. Okay, so let's write the equation. What is like our total that we're trying to work towards? 50 is our total. So let's put 50 as our total. Okay. Which number is the constant? Like which number is 20 is going to stay 20 no matter what, because we're going to buy $20 worth of concessions. That dollar amount's not going to change. Okay. Now, $7 per ticket, that's going to change. We don't know how many tickets we're buying. So that could need $7, $14, $21. We're not really sure. So 7T is what we're going to add right there. Oh, yes, yes. Addition can go either way. It's called the commutative property. So if you write this as 7T plus 20, it's the same thing as 20 plus 7T. Okay. Harper, what should we do first to solve this equation? That's minus 20. Good. Okay. Ooh. We get 30. Well, but in our equation, we get 30. Okay. And so then you're a little worried because when we divide both sides by 7, we get 4.3. Okay, now that concerns me. Well, I can't buy 4.3 tickets, can I?
No, you can buy 4.
Okay, so let's talk about it. I have a $50 bill. That'd be nice, right? I have a $50 bill. I know I want $20 of concessions. How many tickets can I buy? So it might not be add up to exactly 50. Like, does that make sense? All right, so we're gonna have a couple dollars left over if we buy 4 tickets. Okay, I'm not buying 4.3 tickets. I'm buying 4 tickets, and it's just not gonna add up to 50, and I'll have $2 left to put in my pocket. All right, you and your elbow partner, I want you to work through example 3.
The $75 fee. Yeah. So the $75 fee is the one that will never change. So that'll be.
$20 an hour. And then the total would be
You okay, Cordell?
Just hold on. I'm kind of Cordell.
Yeah.
Was a decimal. So then we just,
Was it like a
it was
0.25?
like, yeah, so we
Okay.
just do it like 5.5.
You could say 5.25. Well, what was it? 5.1?
5.2.
Yeah, that's fine. Because if you think about like somebody
So
coming,
like for the solution.
so like, does it make sense if somebody spent 5.25 hours working on something? Yeah, like that's like 5 hours and 15 minutes. Yeah, so that's fine to have a decimal answer. It doesn't make sense for like tickets, but if we're talking about hours, we can have 5.
If we just rounded up like 5.5.
No. Because then it would be a
For
different amount.
hours, wouldn't it be 5.2?
It would be 5 hours and 15 minutes is what 5.25 represents. Are you getting in decimal? That's fine.
Wait.
5.25, yeah. Hold on.
Yeah.
Okay, so Trent, what variable did you use? So S is how long? in hours, right? Okay, so we should have a total of $180. 75 is the flat fee. It doesn't change, but then there's $20 for every hour. So this should be your equation. Check it. Okay, so did you subtract 75 from both sides? So 20S equals 105, and some of you are like, oh no, because I know that 105 divided by 20 is not gonna be an exact integer. That's okay. Did you get like 5.25?
Yeah.
Okay, let's talk about how that makes sense. Can it take a portion of an hour to work on something? Yeah, so it took him 5 hours and a quarter of an hour. What's a quarter of an hour? 15 minutes. So it took this person 5 hours plus 15 minutes to work. That makes sense. In this case, a decimal's okay. All right. Okay, so this is what I want you to do. I'm gonna let you start on your homework, and I'm going to find it. Okay. There are, it looks like 11 problems. You need to do all of the first page. So write, you need to do all the problems on page 14. So write all the problems on page 14. Then I want you to pick 2 on page 15. I'll let you choose. You pick 2 of those. So total, how many problems are you doing? 7. Okay. You'll do a total of 7 problems. Example is number 1. Okay. So you're doing a total of 7 problems, all of page 14, and pick 2 problems on page 15. And you can get started.